Hey y'all, welcome back to Math Rescue. I'm Andre, a certified math coach. In this video, we're going to talk about expanding binomials using the binomial theorem. If you take in probability and statistics, this is going to click pretty fast because the pattern uses the exact same combinations you saw back then. Once you see how the coefficients and exponents and structure all line up, the whole theorem becomes way less intimidating. Let's talk about it. We have a word problem here that's calling for us to use the binomial theorem to expand. But we're not going to do this one with Pascal's triangle like we did in previous videos. In this one, we're going to use the binomial theorem. The question says, in a board game, a player rolls a special die 6 times. Each roll has an equal chance of being a star with the variable s or a circle represented by the variable c. Find the number of ways the player could get exactly 3 stars and 3 circles by expanding the binomial. So remember that we call this structure here a binomial because it has 2 terms. And we know we need to expand it because we have an exponent here. It'd be the same as like saying like x to the 6th power. It means x times x times x times x times x times x. So instead of doing that out the long way, one shortcut that we can use is Pascal's triangle. Another is called the binomial theorem. So to start, so the binomial theorem uses combinations, and it uses combination notation. So each coefficient is going to be generated using our combination notation. Let me just go ahead and start that. So the first term is going to be center marker here. The first term is going to be 6, 2, 0. The second term is going to be 6, choose 1. We're going to keep doing this all the way down. I might not be giving myself enough space here, but it's okay. And then we finish with 6, choose 6. Let me spread these out just a little bit. All right, so then I'm going to go ahead and put the variables on. So I'm going to start with s. And this is going to have descending powers starting from 6. So to the 6th power, to the 5th power, the 4th power, the 3rd, the 2nd, the 1st, and the 0 power. Then we're going to start with c. Same thing here. These are going to start from 0 and ascend. So we'll do the 0 power, the 1st, the 2nd, 3rd, 4th, 5th, and 6th. There is an addition sign here in the middle, so I'll go ahead and separate all of these terms with a plus sign. Now I can clean it up. So anything to the 0 power is just going to be 1. So, and 1 times anything really doesn't make an effect, so it just kind of disappears. So I could go ahead and erase my 0 powers. To the 1st power is just that value, so I can go ahead and erase the exponent of 1. I'm just kind of cleaning up and simplifying now. This. All right. Now, if you haven't taken probability and statistics before, you may not know what to do with our combination notation. So the problem is looking for this term right here. And it's really looking for the coefficient. So specifically, it's looking for this piece right here. I really like the Desmos calculator. In the Desmos calculator, this goes in as follows. And then the Desmos calculator will give me a value of 20. Some calculators will actually take it just like that. So they'll let you put a 6, a C, and then a 3. And it'll just give you the same result, 20. That so you can see it. So for the actual question where it says identify the term representing exactly 3 stars in 3 circles, it is a coefficient of 20. So that's the term there. I'm Andre with Math Rescue. See you in the next one.